In this video, we are going to talk about using the law of cosines. So recall from geometry when you learned about proving that triangles were congruent using side, 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 side angle, side, that kind of thing. So when we did that, we had 5 different ways that we could prove that triangles were congruent. And what that really means is that there's only one triangle with those 3 measurements. So we did side, 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 angle, side. Those are the 2 we're going to be kind of talking about today with law of cosines. You also had angle, side, angle, and you had angle, angle, side, and then you had hypotenuse, leg. So these were the 5 ways that if we saw measurements, that meant there was only one distinct triangle that could be made. So if I gave all of you 3 sticks, the same size as everybody else, so each of you got a 3-inch stick, a 4-inch stick, and a 5-inch stick, and I said make a triangle, every single person would make the exact same triangle. Okay, you would all make a triangle, even if it was rotated, but it would end up being a 90-degree angle. It would be a right triangle, okay, and you'd have these, the 3-leg and the 4-leg would make that right angle, and then the 5 would be the hypotenuse. That's the only way to make a triangle with the lengths of 3, 4, and 5. If I gave you 2 sides and the angle that connected them, again, so if I gave you a 2-inch side, a 3-inch side, and said in between there, you need to put a 50-degree angle, everybody would make the exact same triangle, okay? And so on with all of these. So that's what we're talking about here is there's only one triangle with those measurements for side, 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 and side, angle, side. The rest of these as well, we'll get to them later. So then if you did know it was a right triangle, so when we had a right triangle, we could actually use right triangle trig, SOHCAHTOA, to help us solve it. Meaning if you knew at least a few pieces of information, so you knew it was a right triangle, if you had an angle and 1 side length, you could solve for the rest. Or if you had 2 side lengths without the angle, so if you just knew 2 side lengths, you'd be able to solve for this missing side with Pythagorean theorem and these 2 angles with inverse trig. Okay, so what about if we don't know that it's a right triangle? Because up until this point, we've only ever solved right triangles with SOHCAHTOA. So what if I gave you this and you knew that this side length was 2, this one was 5? Could you get me this, 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 and this? Okay, so could you tell me all 3 angles and the side? And that's where law of cosines comes in, and later law of sines. So for law of cosines, these are the 3 formulas. Okay, now I only ever remember one of them, and then I just remember how they're set up. So take a look here. You've got one side that's squared. Okay, so if I'm doing a squared, then I've got b squared and c squared. Okay, then minus 2bc, so bc are these 2 side lengths here, cosine of a. Okay, so a matches with the one that's by itself way over here. So if I'm doing b squared by itself, so b squared then equals a squared plus b squared, or sorry, a squared plus c squared, then it'd be minus 2ac. Okay, so notice these are the same. And then that b is going to be cosine of angle b. C squared, then you'd have the a and the b squared, minus 2ab, and then cosine of c, the angle that's over here, okay? Now these little lowercase letters are the sides. The uppercase letters are the angles. So if we did this, this would be a, b, c for capital letters for the angles. Then directly across from angle A would be side A, the lowercase. Across from angle B would be side B, and across from angle C would be side C. Okay, so it is appropriate to use law of cosines when you have all 3 sides given to you, or you have 2 sides and the included angle, the angle between. Okay, so if you saw something like this and you knew all 3 sides here, you had something like this, then you could use law of cosines to solve for those missing angles. Or if you had something like this, where you had a side, and then the angle in between these, okay, then you could use law of cosines. So not anything else, okay? So not if you had this side, this angle, and then this angle, okay? That angle is not between these two sides, so you would not use law of cosines for this, okay? It has to be all three sides or two sides and the angle between those two sides. Okay, so let's take a look at a couple examples here. So we've got in triangle QRS, side Q is 370, side R is 910, and angle S is 31. So let's write that on the picture. I also like to organize my information like this, so I've written down all of the angles and the sides. So remember, side Q, lowercase q, is across from angle Q. So 370 over here. Side R is 910, so across from angle R, so 910. And then I'm going to write those over here as well. And then angle S is 31 degrees. So now when we take, a look at this, when you're deciding if you're going to be using law of sines or cosines, take a look at what sides. So we've got two sides given to us, and then the angle in between those two sides. So this would be a side angle side idea, and that's going to be law of cosines, okay? So now when you go ahead and set up your law of cosines, so you can, the law of cosines that we talked about has A's, B's, and C's in it, right? But this is Q, R, and S. Okay, so it has to do with setting up which side or angle you're going to solve for. So we're looking here, like we're going to solve for side S first because it's the one that's missing. So we're going to be looking at side S. So when I go to set up this formula, it's going to be S squared equals, and then the other two sides, okay, so R squared plus Q squared minus 2, and then these two sides, so 2 times side R times side Q, cosine of the angle that's over here, okay? So we've got side S over here, so we're going to be doing angle S in our cosine. Okay, that's how you're going to set up the law of cosines formula. So now we'll plug in information, okay? So we are missing the S, side S, so we'll have S squared equals side R squared, so R is 910, so we have 910 squared, side Q is 370, okay, minus 2 times 910 times 370 times cosine of angle S, which is 31. So when you go to calculate this, make sure that your calculator is in degree mode since our angle is in degree mode, okay? So I'm just going to use the Delta Math calculator here since all of you have access to that. So our variable is way over here on the left, so I'm just going to be able to actually just type this in just like it looks, okay? So I'm going to do 910 squared plus 370 squared, and you don't have to have parentheses around that because there's nothing extra in there, so I'll just do it both ways. And then minus 2. And again, you don't have to have these parentheses here. You could just put multiplications because there's nothing within the parenthesis to simplify, but if you like to have it look just like it looks written, it's kind of nice to put the parentheses in. And then functions to get your cosine. Again, remember that make sure you're in degree mode. Okay, and so then we're going to want cosine of 31. Okay, and so now that is S squared. Okay, so we have S squared equals, and we just calculated all that. So 387,783. So S squared equals 387,000. I forgot what it was. 783.5397. Okay, so that's what S squared is. So now we'll square root both sides, and that will get you what S equals. Okay, so just in your calculator, just put square root of the answer, and it'll kick that answer back in, and you'll get this, 622.72. and then make sure you look at what the question wants. So this question wanted our answer to the nearest centimeter, so to the nearest whole number. So then we would say S equals 623 centimeters for side S. And so that would be this one. And then that's what they actually wanted, was just for us to solve for S. Okay, next one. So triangle FGH, side F is 65. So across from angle F is 65 inches. Across from angle G is 48 inches. And then across from H is 70 inches. Okay, so we've got side G is 48, side F is 65, and then side H is 70. So in this one, they want us to solve for angle G. So we are looking for this for our answer. We've got all three sides given to us. So this is a side, 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 meaning that we would do law of cosines. Okay, so in this case, thinking about what angle we want to solve for will help us set up the cosine function. Okay, so we're going for G first. That means that I want to set up the law of cosines, okay, that has angle G in here, okay? So what, remember that the angle within the function matches the side that you start with, okay? So if we want to be solving for angle G, we need to start with side G. So when I set up this function, I'm going to do G squared equals, okay, and then F squared plus H squared for the sides minus 2FH cosine of angle G. Okay, so remember that the G side G over here matches the angle that's in here. And I used that one because I want to solve for angle G. Okay, so that's why I set it up this way. So now you can plug in your information. So side G is 48. So we'll do 48 squared equals 65 squared plus 70 squared minus 2 times 65 times 70, and then cosine of G. Okay, so now this time our variable is stuck in this cosine function. So we're not going to be able to just immediately solve like we kind of did last time where we just typed it straight into our calculator. Okay, so figure out, so do 48 squared and write that down. So 48 squared is 2,304. Then do 65 squared, which is 4,225. Do 70 squared, which is 4,900. Okay, then multiply this together. Okay, so all of this is multiplication here. So these you can all multiply together. So 2 times 65 times 70 gives you 9,100. So you have 9,100 here, cosine of G. Okay, so remember this cosine of G is what we are trying to isolate. Okay, so this is our variable. So we can combine these right here. So we'll get 2,304 equals, add those together. So 4,900 plus 4,225 gives you 9,125 minus 9,100 cosine of G. Okay, a lot of people make the mistake of trying to combine these. Okay, those cannot be combined. This is like you have 9,125 minus 9,100x, right? Those are not like terms. You can't combine those, okay? So be careful with that. You want to just isolate this. So we're going to subtract 9,125 from both sides. So 2,304 minus 9,125. So you will get negative 6,821 equals negative 9,100 cosine of G. So to isolate that cosine, we'll divide by negative 9,100 to both sides. And then you'll get, so 6821 divided by 9,100. So the negatives cancel out, so you get 0.74956 dot 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 in your calculator equals cosine of G. To get the angle out of here, remember you do inverse cosine. Okay, so we'll do cosine inverse of 0.74956 to get what G is. Make sure your calculator is in degree mode. Do cosine inverse, and you should get that G equals 41.44 degrees. So then again, take a look at what the question wanted. It wants to the nearest degree. Okay, so we had 41.44, which rounds to 41 degrees. All right, then let's take a look at one word problem. So we've got two airplanes flying in formation, taking off in different direction. One flies due east, okay, meaning directly to the right, okay, right? So you've got, north, south, east, east, and west, okay? So if you don't know, so north, south, east, and west. Okay, so we have this plane and it's taking off. It's going to fly due east at 350 miles per hour. Okay, another plane flies north 20 degrees east. So what this means is 20 degrees east of north. Okay, so here's due north. This plane is flying 20 degrees off of that due north. Okay, so this angle right here is 20 degrees. So if I draw that over here, okay, here's north. This one's going to go 20 degrees off of north. Okay, I'm just going to draw the due north on there with a dotted line so you can see it. And so we can deal with that angle. Okay, so this is 20 degrees right here. Now remember how far they flew. So let's just do an hour just to make it easy. Okay, so let's pretend both planes have flown for an hour. So this plane going due east has gone 350 miles in that 1 hour. Okay, and this plane flying 20 degrees off of north has gone 380 miles in that 1 hour. Okay, and then we want to know how far apart are they? Okay, so how far apart are they? So this distance right here is what I want to find. Okay, so that's what I'm trying to come up with. So we've got two sides. We would need an angle to be able to do law of cosine. So we can figure out this angle right here. Remember this whole angle, okay, this angle right here is a 90-degree angle. Okay, so we know this part of it's 20. That means this needs to be 70 degrees to total that 90. And then that gives us our triangle. So you can label this if it's easier for you to say A, B, and C here. So then you can see that you have side C, you have side B, you're looking for side A, if that helps you in creating the law of sines and cosines. I don't know why it left that mark there. Sorry about that. So we're looking for side A, so we're going to do A squared equals, so then it would be B squared plus C squared, the other two sides, minus 2BC cosine of angle A. So side A we don't know. B is 350 squared, C is 380 squared, minus 2 times B, which is 350, C, which is 380, and then cosine of A, angle A is 70 degrees. So then, again, we can just type this into our calculators, okay, just like it looks since our variable is over here. So I'm just going to clear this out. All right, so we've got 350 squared plus 380 squared minus 2 times 350 times 380, and then we want cosine in degree mode, okay, so cosine in degree mode of 70. Okay, so that's our A squared. So then to get A, we would square root that answer, and we'd get 419.43. Okay, and then this one didn't ask us to round anything, so we'll just do 419.4. And really, you probably, in miles, it's not going to matter if you have 0.4 of a mile. Really, you could say 419, whoops, not A squared, 419 miles would be fine as well.